Assalamu alaikum warahmatullahi wabarakatuh. My name is Mohammed Mukriz and this is our group's video presentation for Assessment 2 MAT183. These are our group members, myself, Muhammad Haikal bin Hamadi, and Muhammad Izzuddin Ashraf bin Shahram. Now for the first question, what is differentiation? Differentiation is the process of finding the derivative of a function. For instance, the rate of change of something, the slope of a tangent, the maximum or minimum point of a function, and much, much more. In calculus, finding the derivatives of a function require different methods for certain types of expressions. What that basically means is that to find a derivative of a function, we can't use the same method for every type of expressions. That is where techniques of differentiation comes in. Each unique technique targets a specific type of expression, and we refer to most of those techniques as rules. The first one here is power rule. Power rule is used for this type of function, fx equals to x to the power of n, in which case we will use this formula, n times x to the power of n minus 1 times x prime. X prime here is basically refers to the derivative of x. Now, and the next one is product rule. Product rule is used to find this type of function, fx equals to ux times vx, where u and v are each different types of expressions, in which case we will use uv prime minus vu prime. The next one is quotient rule. Quotient rule is basically the same as product rule. However, the only difference is ux is divided by vx, in which case we will use this formula here, vu prime minus uv prime over v squared. Now there are a lot of rules beside this, but these are the only ones I can show you for now. Now on to question 2. Question 2 are as follows. Find dy dx for the following functions. A. 3x squared secant x plus 2. From this expression, we can see that 3x squared and secant x plus 2 are two different types of expressions. And so we will divide them. U is 3x squared, v is secant x plus 2. U equals to 3x squared. By using power rule, u prime equals to 6x. V equals to secant x plus 2. By using trigo rule, v prime equals to secant x plus 2 tan x plus 2. Put them into this formula, uv prime minus vu prime, 3x squared times secant x plus 2 tangent x plus 2 minus secant x plus 2, 6x. Now we can factorize this. First of all, identify the common terms from both sides, secant x plus 2, secant x plus 2, 3x squared, 6x. And number 2, factorize. 3x secant x plus 2, x tangent x plus 2 minus 2. Now, for b, y equals to 4x plus 2 over cos x. Now, we will use product rule. U for the denominator, U for the numerator, v for the denominator. U equals to 4x plus 2, using power rule, u prime equals to 4 times 1 equals to 4. V equals to cos x, using trigo rule, v prime equals to negative sine x. Put them into this formula, y prime equals to vu prime minus uv prime over v squared. Cos x times 4 minus 4x plus 2 times negative sine x over cos x squared. 4 cos x minus negative 4x sine x minus 2 sine x over cos x squared. And we will expand negative 1 here onto both expressions. 4 cos x plus 4x sine x plus 2 sine x over cos x squared.
Move to the next question. given y ln 3x minus e to x plus 1 minus tan for y equals 0. Find dy dx using implicit differentiation. First of all, y ln 3x is two different things. It is because y is algorithm term and ln 3x is logarithm function. So to differentiate it, we need to use the product rule. So uv prime minus du prime is the formula. U equal y, u prime equal 1 dy dx. V equal ln 3x, v prime equal 1 over 3x times 3x prime equal 1 over 3x times 3 equal 3x of 3 over 3x equal 1 over x. Then e to x plus 1 and tan for y, we can differentiate it like usual. After all of that, we can enter it to the formula like this. Uh, then we times u times with v times with u prime to get this one. And then we separate dy dx term to the left and another term to the right, like ln 3x dy dx, dy over dx, and so on. After that, we factorize dy dx. So we get ln 3x minus 4 second square for y. Then lastly, this bracket, we bring it to the right. So it will be 2e to x plus 1 minus 1 over x, y over ln 3x minus 4 second square for y. That's all.
For the last question is about linear approximation to estimate the value to get three decimal place. For the question, we have fourth, fourth root of 80.99 minus minus 2 over square root 80.99. For the first step, we need to identify the x, which is usually a rational number, fractional number, irrational expression, and so on. And now we know that 80.99 is the x, so we need to replace it to x, and then we need to convert the root to powers, and then we will have x power 1 over 4 minus 2x power negative 1 over 2. For the second step, we need to differentiate the function, like and then we will have 1 over 4 x power 3 over 4 plus x power negative 3 over 2. For the third step, we know the x is equal to 18.99, and we need to create the new variable, which is x node. And for its value, it needs to fit in two conditions. For the first is need closest to the x, and the second is it can fit in under the root of the in the equation without be a decimal or without be a fractional number. And then we need to subtract the x to x node, and then we will have negative 0.01. For the fourth step, uh, we need to change the x to x node in the function that we have in the before and after differentiation. And since we know the x node is equal to 81, so we change the x node to 81, and then we will have and then to the function of before differentiation, we have 2.7778, and after differentiation we have 0.010631. For the last step, we need to find fx. In order to find it, we know that f we know that it's equal to f times x naught plus the change of x. And then in order to find this, we need to expand, and it will be f x naught plus f prime x naught times the change of x. And then we will have 2.7778 plus 0.010631 times negative 0.01. The result, it will be 2.77789. Since the question wants the answer in 3 decimal place, so the answer will be approximately 2.778. Okay, in conclusion, technique of differentiation is related to power rule, sum and difference rule, product rule, quotient rule, chain rule, and implicit differentiation. Differentiation is a fundamental tool in calculus, enabling the analysis of how functions change. Mastery of this technique is essential for solving real-world problems. Thank. That's all from us. Thank you.